Okay, so I welcome you all to this lecture on electrostatics, right? In last lecture, we have started with the second unit, that is electrostatic, and we discussed about Coulomb's law. So very quickly, we will review what we discussed about Coulomb's law, and then we will extend the idea of Coulomb's law to understand further things, right? So I hope my screen is visible to everyone. If not, you please interrupt me. So we are talking about Coulomb's law, right? And we know that there are types of charges like proton, electrons, right? So proton will have a positive charge, electrons will have a negative charge. And we have seen if two charges comes into the vicinity, and if they are like charges, means both the charges will have similar polarity, then they will repel each other. And if the charges are having opposite polarity, means one charge is positive and another charge is like a negative charge, then in that case, if they comes closer, then they will attract each other. So from this phenomena, they repel each other or they attract each other, we can easily say that there exists a force between those two charges. And here at this moment, Coulomb started his experiment to identify this force, because a force is existing, right? So after observing the existence of force, Coulomb's in 1785, I guess I told you, he started his experiment, and he has taken two charges like Q1 and Q2. So let's assume we have Q1 here and we have Q2 here, and this is the distance between those two charges. So for example, let us assume the distance between those two charges is R, and we have defined a Coulomb's law for this assumption. We have two charges Q1 and Q2 separated by distance R. In that case, the force acting between those two charges can be written as the force between those 2 point charges, that is Q1 and Q2. It is directly proportional to the product of those magnitudes of the charges, and inversely proportional to the square of the distance between the two charges, right? So mathematically, this can be written as F is the force, right? I'm talking about magnitude only. Later on, we will talk about the direction, but for a while, let us understand the magnitude. Magnitude of force is directly proportional to, as per Coulomb's law, it is directly proportional to product of the magnitudes, means Q1, Q2, divided by, means inversely proportional to square of distance between them, means R square. Right, so this is what the Coulomb's law is. This part we have seen in the last lecture. Now let us understand, let us proceed further to understand further things, right? Since it is a kind of proportionality, I can easily say here F is the force acting between those two charges. It is equal to, instead of this proportionality, what I'll write is K. K is constant of that proportionality, and Q1 Q2 upon R square, right? So this will remains as it is. Now, what is this K? K is nothing but constant of proportionality. K is a constant, right? And on what parameter it depends? It's a constant of proportionality. Constant of proportionality, and it depends on medium. It depends on medium, right? So I hope you understand what I'm trying to tell. So this K is actually a constant term. It's a constant term. It will not change because the medium between those two charges will not change, and it depends upon the medium, right? So for a particular medium, K is a constant. And let me write here the formula for K. K is equal to 1 upon 4 pi epsilon naught. 4 pi epsilon naught. See, this epsilon naught, very specifically, I am defining for free space. Let me write here, epsilon naught is permittivity of free space. Is a permittivity of free space. So what is my assumption? The medium between Q1 and Q2 is free space. Q1 and Q2 च्या मध्ये जे medium आहे, that I am assuming as a free space. And for free space, permittivity is epsilon 0. And what is the value for epsilon naught? Epsilon naught, value of epsilon naught is equal to 8.854 into 10 raised to minus 12 into 10 raised to minus 12. The unit of permittivity is farad per meter. This is one. This is constant for free space. For free space, permittivity is 8.854 into 10 raised to minus 12. So I expect all the students should note this value, because every now and then, almost in every examples, you have to use this value. You have to use this value. So this is a constant for free space, and the value for free space, that is permittivity, epsilon naught value for free space is 8.854 into 10 raised to minus 12. It is constant, right? So in examination, in case of some examples, they will assume, they will consider either free space. They will assume either a free space condition in which you have to assume the value of epsilon naught, which I have written here, or they may give you some they may give you some medium 1. In that case, you will be provided with the value epsilon 1. This epsilon 1 will be the permittivity of that medium, right? So in examination, if example is expecting some value from epsilon naught, in that case, free space is assumed, and we have the constant value for free space. If they have specified some medium, then the value of epsilon 1 would be given in that case. थोडक्यात सांगतो, एक्झाम्पल मध्ये फ्री स्पेस कंडिशन अज्युम केलेली असते. परमिटिव्हिटीची व्हॅल्यू तुम्हाला जी माहित आहे 8.854 इंटू 10 रेज टू मायनस 12 ही बाय डिफॉल्ट कन्सिडर करायची. जर त्या एक्झाम्पल मध्ये वेगळं मीडियम दिलेलं असेल, फॉर एक्झाम्पल मीडियम 1 हे काहीही असू शकतं, तर त्या मीडियम सोबत त्याची परमिटिव्हिटी त्या एक्झाम्पल मध्ये दिली जाईल आणि ती परमिटिव्हिटी तुम्हाला त्या एक्झाम्पल पुरती कन्सिडर करायची. ठीक आहे? I hope you understand what I mean to say. So for free space, it's 8.854 into 10 raised to minus 12 farad per meter. I hope you remember this. Let me tell you another value. If you calculate that, you will find the same. And this value is used for calculation simplicity. The value is same, but for calculation simplicity, we can consider this as 1 upon 36 pi. This is for calculation simplicity. So 1 upon 36 pi into 10 raised to minus 9, unit is same, farad per meter. So either you go for this or you can go for this. For calculation simplicity, we use this value. This is for This is for calculation simplicity. Right? So this value, if you calculate, it's obviously it's fixed, it's same value. But for calculation simplicity, as I said, if you can observe this formula, if you can observe this, it's having this 4 pi, 1 upon 4 pi. So when you take this as a 36 pi, this pi gets cancelled, right? So this is for just for calculation simplicity. Either you can go for 8.854 into 10 raised to minus 12, or you can go for 1 upon 36 pi into 10 raised to minus 9 farad per meter is the same, right? This is for free space. This is for free space, farad per meter. Now, finally, now I can write the Coulomb's law, final Coulomb's law. This is again a magnitude of force between 2 point charges. Q1 is the first point charge, Q2 is the another point charge, divided by 4 pi epsilon naught. 4 pi epsilon naught r square. This is the magnitude of force as per the Coulomb's law. This is as per Coulomb's law. Is it clear up to this point? Any doubt so far? I have written the formula for Coulomb's law, exact formula for Coulomb's law. Am I audible?
Yes, sir.
Okay. इथपर्यंत काही डाऊट आहे कुणाला? Shall we proceed further?
Yes, sir.
Okay, so we can proceed further. इथपर्यंत जर काही डाऊट असेल तर इथंच विचारा, so that it will be easy to handle those doubts, because once we move ahead, it will be little bit difficult to repeat everything. इथपर्यंत जर काही डाऊट असेल तर विचारा आताच. कुलोम्स लॉ ने आपण फोर्स कॅल्क्युलेट करतो. फोर्स साठी मी ऍज पर कुलोम्स लॉ फोर्स काय असतो? इट्स डायरेक्टली प्रोपोर्शनल टू प्रोडक्ट ऑफ दोज चार्जेस and it is inversely proportional to square of distance between them. So from that I have written this. We can write this, right? So this is Coulomb's law. त्यानंतर मी काय म्हटलं? Since it is a proportionality, I have considered K as a constant of proportionality. K is a constant of proportionality and it depends upon the medium between those two charges. So its value is K is equal to 1 upon 4 pi epsilon naught. Epsilon naught का मतलब मी by considering free space. For free space, permittivity is constant. Its value is 8.854 into 10 raised to minus 12. Or you can use for notational simplicity as 1 upon 36 pi into 10 raised to minus 9 farad per meter. Right? So this is what the Coulomb's law is. Now we are moving towards next step. Next step is the vector representation. Vector representation means what? The direction. Now we are trying to involve the direction. We are trying to involve the direction. So in first case, let's say, just a minute. Vector representation. What do you mean by vector representation? Because in earlier equation, we have seen it's a magnitude. Now we are interested in a direction, right? So to understand the direction, what I'll do is, I will once again draw those two charges. Let's say Q1 here. Let's say Q2 here. Q1, Q2. And these two are separated by distance R1. These two are separated by distance R1. These two are separated by distance r. Sorry, it's r. Now I have drawn arrow here on a q2. That means the vector is from q1 to q2, right? So in that case, what I'll represent here r12. R12 is the distance between q1 to q2, right? So this way I can represent a direction. In that case, I can define the formula which I have written here, right? So this is your Coulomb's law. So here the law becomes I can write here. Now this law would be giving you the force on q2 because of q1, and we will call it as F12. F12 bar means what? It is a force on q1 because of force on q2 because of q1. F12 is a force on q2 because of q1. This is equal to q1 q2 as it is divided by 4 pi epsilon naught as it is. 4 pi epsilon naught as it is. Here the distance would be r12 square into, now here we have to give the direction, and what is the direction? We have to specify the direction in which the vector is. So that would be a bar r12, that is unit vector in that direction. So direction is a bar r12, right? So this is the direction. This is one case. If I want to find the force on q2 because of q1, this is the formula, or this is what vector representation is. Next case is reverse. Next case is opposite. Means what? Here you are having q1. Here you are having q2, right? And the vector direction is opposite. This is your vector, right? So I can draw the arrow at q1. So here in this case, distance is same. Your distance is same, but the direction is changed. So I can write the distance is same like r, but here suffix will change, r21. Magnitude is same, but I'm changing the notation because it is from q1 to, sorry, q2 to q1. That's why r21. R21 is the distance now. And in that case, unit vector would be a bar r21. A bar r21. Hence the force F21. F21 is the force on q1 because of q2. It is equal to a q1 q2 upon 4 pi epsilon naught r21 square into a bar r21. A bar r21. This is the vector representation of Coulomb's law. This is vector representation of Coulomb's law. Is it making sense? Do you understand this? What I have written? Coulomb's law we have seen yesterday only. Coulomb's law आपण कालच बघितला होता. आज फक्त आपण कोणत्या डायरेक्शनचा फोर्स काढतोय त्याच्या अगेन्स्ट दोन फॉर्म्युले इथं लिहिलेले आहेत, F12 आणि F21. F12 म्हणजे फोर्स ऑन Q2. यालाच काय म्हणता येईल? यालाच काय म्हणता येईल? जस्ट अ मिनिट. This F12 म्हणजे काय? F12 is force on Q2 due to Q1 आणि याला F21 ला काय म्हणता येईल? This is force on force on Q1 due to Q2. I hope you have noted these points, because based on this we are going to solve next example. We are going to solve the examples now. Have you noted this, or you want a time to note this? Yeah, by the time I'll take the attendance, you can note down the points. I will take the attendance by the time. Based on this, we are going to solve one example immediately. So I want every one of you to note down those formulae. Yes, so roll number 1, 2, 3. Roll number 3. Roll number 6. Roll number 10. Roll number 16, 1 6. Roll number 20. Roll number 29. 31. 32. Roll number 32. 34. 36. 40. Roll number 40. 41. 43. 46. 47. 48. 51. Let me repeat the roll numbers: 3, 6, 10, 16, 20, 29, 31, 32, 34, 36, 40, 41, 43, 46, 47, 48, 51. Anyone out of this is present in the class? Okay, fine. So I hope you have noted all the formulae which I have written here. So let's move ahead. But before we go to the actually solving the examples, I hope you will note down few of the steps which I'm going to write here. So these are the steps which you have to follow while solving the examples, right? So while solving the examples, steps to follow. Number 1, or you can say step 1. Step one is draw a neat sketch. Draw a neat sketch. Draw a neat sketch. Now why I am saying this? Why I am saying this? Because in the example, they give a proper scenario without missing any of the information. They give proper scenario. You have to identify them. And once you identify the scenario, you have to draw the proper sketch of that scenario. Then step 2. Step 2 is find a vector joining the charges. Find the vector joining the find the vector joining the charges. Right, so find the vector joining the charges means what? If q1 is here, q2 is here, and if you are asked to find some force, so you have to find that vector, let it be from q1 to q2 or from q2 to q1. So that vector is to be find out as a second step. Then find unit vector in that direction. Find unit vector in that direction. Find the unit vector in that direction. So once you find a vector joining these charges and find the unit vector in that direction, then you can go ahead for finding. You can, let's say here, step 5, step 3. Find the force. Find the force between the charges using Coulomb's law. That is important. Find the force between the charges by using the formula, by using the Coulomb's law. So where you will find the Coulomb's law? On a previous slide I told you F12 or F21 is the Coulomb's law, right? So I hope you have noted those steps, and with those steps, let's move ahead to solve one of the example. Shall we solve one example?
Yes, sir.
Okay. Right. So try to understand the scenario from given example. I'll try to write the scenario. I'll try to write the example. So for writing the example, I will use blue color. Example. A point charge Q1. A point. I hope every one of you will write along with me, so that there will not be a time lapses. A point charge Q1 equal to 2 millicoulomb, equal to 2 millicoulomb is located in a free space, is located in free space, is located in free space at P1, into bracket -3, comma 7, comma -4, while Q2 equal to 5 millicoulomb is at P2 into bracket 2, comma 4, comma -1. Find F21, or let's say find F12 bar and F21 bar. म्हणजे आपल्याला इथं F1 Q1 वरचा पण फोर्स काढायचा आणि Q2 वरचा पण फोर्स काढायचा. Now read this example carefully and tell me what information you can have. What information you are having here. See, one by one, let us move ahead. A point charge. So first information is you have a point charge. You have a point charge. I'm doing this rough work, point charge, because you may have, sometimes you may have line charge, sometimes you may have surface charge, sometimes you may have volume charge, right? But right now we are not talking about those line charge, surface charge and volume charge. We are talking about point charge only, right? The next you have Q1 and Q2. You have Q1 and Q2. That means 2 point charges. 2 point charges are mentioned. Now next thing is where they have mentioned. Number one, they have mentioned it is located in free space. So the medium is equal to free space. The medium between the two charges is free space. And we know that for free space, what are the assumptions? Epsilon naught. Epsilon naught is equal to 1 upon 36 pi into 10 raised to can someone tell?
-9.
Correct, -9 farad per meter. This is how you can read the example. So for medium is free space, epsilon naught is 1 upon 36 pi into 10 raised to -9. Next thing is they have mentioned P1 and P2 for the location of Q1 and Q2, right? P1 and P2. If you could see the points, both the points they have specified with respect to X, Y, Z. That means both the points are in a rectangular coordinate system. Sometimes they specify one point in a rectangle. They specify one point in rectangle and one point in, let's say, another coordinate system. In that case, you have to convert back into a rectangular coordinate system, right? And then you can find out the vector. Now here we are going to use those 3 steps which I told you just now. Now we will use those 3 steps. Now let's move ahead to solve this example by using those 3 steps. Now tell me, can someone tell me the first step of that? Draw a neat sketch. You have to draw the neat diagram from given information, right? So from given information, I can draw here the diagram, right? So you have Q1 here. You have this Q1 here, which is located at P1. And what are the coordinates of P1? P1 is -3, 7, 4. Sorry, -4. And we have Q2. We have Q2 at P2. Q2 at P2. And what are the coordinates of P2 given? 2, 4, -1. Right? And first, they have asked to find F12 bar. Right? So that means we have to identify the force from Q1 to Q2. So this force we have to find out. Right? So this would be the direction of F12. So let us assume the distance between those 2 point charges is R12, as I said earlier. So this would be the vector, and this direction would be given by A bar R12. Right? So this is the unit vector of this vector. Right? So we have formula to obtain this force. We have what we have is F, just a minute, that has to be a capital letter. F12 bar, it is equal to Q1, Q2 upon 4 pi epsilon naught, 4 pi epsilon naught. Right? Why I have taken epsilon naught? Because it is a free space. If some other medium is given, that value I will take here as epsilon naught into R12 square A bar R12. So this formula I have to use to calculate force on Q2 due to Q1. So this is the formula. This formula we are going to use. Now this is step 1. I have done with the step 1. Now step 2. What is step 2? What is step 2? Can someone read?
The vector joining these two charges.
Okay. So step 1 is draw a neat sketch. Step 2 is find the vector joining these 2 points. So what vector we have to calculate? R12 bar. R12 bar is to be calculated, and also find the unit vector in that direction. So A bar R12 is to be calculated. So this is step 2, right? So let's begin. You have P1 and P2 coordinates are known. So we can easily identify this vector R12 bar. It is equal to end coordinate minus starting coordinate, that you know, right? So that means here it is 2 minus of minus 3, right? So this is 2 and minus of minus 3, A bar X, plus 4 minus 7, 4 minus 7, A bar Y, plus into bracket minus of minus 1 minus of minus 4, right? So this is minus 1 minus of minus 4, A bar Z. It would be A bar Z. So what is the answer for this? What is this vector now? Can someone calculate and tell me the vector R12? It's 5 A bar X, right? Minus 3 A bar Y, minus 3 A bar Y, plus 3 A bar Z. This is your vector. Now you can calculate the unit vector of this. So if this is a vector, how you can calculate the unit vector? Unit vector A bar R12 is equal to, we know that it is a vector upon magnitude. So what is the vector value here? Vector is 5 A bar X minus 3 A bar Y plus 3 A bar Z, right? And divided by under root 5 square plus into bracket minus 3 A bar minus 3 bracket square plus 3 square, right? So this is the unit vector. So that could be under root 43. Now very important step, that is step 3. What is step 3? Is to use the Coulomb's law and find out the force, right? So step 3. Step 3, here I am going to write the formula. F12 bar is equal to Q1 Q2 upon 4 pi epsilon naught R12 square A bar R12. Now put the values. So what are the values? What is the value of Q1? What is the value of Q1?
2.
Okay. So 2 millicoulomb, they have mentioned millicoulomb. Now let me basically give you the difference between all those, and then we can discuss further. So when I say okay, so when I say a tera, what do you mean by that tera? Tera means Tera means 10 raised to 12. When I say giga, it's 10 raised to minus, sorry, 10 raised to plus 9. Then we have mega, right? So I hope you know now. 10 raised to
6.
okay, 10 raised to 6. When I say kilo, 10 raised to
3.
3. Okay. Then when I say only Coulomb, or when I say none, it means 10 raised to 0. 10 raised to 0 means 1, right? So sometimes when I say Coulomb, then that means 10 raised to 0. Then on opposite scale, we have milli, right? So milli means
10 raised to minus 3.
10 raised to minus 3, correct. Then sometimes we have nano. Capital N is the notation. So it would be 10 raised to minus 6. Then we have, sorry, after milli we have micro.
Micro.
Yes, by mistake. Yes. So after this milli, we have micro. And then we have
Nano.
nano. Right? So for nano, we have 10 raised to minus 9.
9.
And then we have pico. For pico,
10 raised to minus 12.
10 raised to minus 12. Correct. Now here in our example, they have mentioned Q1 equal to 2 millicoulomb. Q1 equal to 2 millicoulomb means what? Q1 equal to 2 millicoulomb means what? 10 raised to minus 3. So this is Q1. 2 into 10 raised to minus 3. 2 into 10 raised to minus 3. Multiplied by Q2. Q2 is 5 millicoulomb. Yes. So 5 into 10 raised to minus 3 divided by we have 4 pi, right? So 4 pi here. Epsilon naught is 1 upon 36 pi, right? Into 10 raised to minus 9, right? So this is 10 raised to minus 9 into what is the value of magnitude? Value of magnitude of R12? From this, can someone tell me what is the value of R12? It is under root 43. Stop me if I'm wrong. Interrupt me if I'm wrong. This is the magnitude, right? So here I can write under root 43 bracket square into. Now what is the value of this a bar r12? A bar r12 I have calculated here, right? It is 5 a bar x minus 3 a bar y plus 3 a bar z divided by under root 43. Divided by under root 43. Is that clear up to this point?
Yes, sir.
I just have written the values into the formula. Now next step is to calculate all the numerator parts. So let me highlight here what you have to calculate. So you just have to calculate this part first. Then you can calculate this part.
So upper numerator 1 into 10 raised to minus 5.
1 into 10 raised to
Minus 5.
okay, 1 into 10 raised to minus 5. Next, denominator. So I hope you will calculate those two values by using a calculator. So if you divide these two values, means what? If you could solve this for a single value, what it would be? You please calculate at your own, because if you don't get it value, if you don't get it the way to solve this type of calculation, it will be very difficult. And you may be aware, like recent notification from the universities, anyway you are going to face the final examination in offline mode, right? So this is 319.183. (183) into bracket the vector as it is 5 a bar x minus 3 a bar y plus 3 a bar z. Check whether you are getting this answer or not. If not, you just tell me. Are you getting this value? Someone may get 320, somebody may get 318. That's fine. But are you getting near about this value? 319.183. Are you getting this value? Anyways, is there anyone getting different value than this? तुम्हाला यापेक्षा वेगळी व्हॅल्यू काही येते का? ओके, म्हणजे सेम व्हॅल्यू पण येत नाही, वेगळी व्हॅल्यू पण येत नाही. दॅट सिम्पली मीन्स यू आर नॉट सॉल्विंग. So this in future going to create a problem. This in future going to create a problem. right? So with this, let's move ahead. If you could multiply this into the bracket, final answer you will be getting. It is equal to, I'm writing it in kilonewton now. So it would be 1.596 1.596 a bar x minus 0.957 a bar y plus 0.957 a bar z, and the unit of this is kilonewton. This has to be 10 into 10 raised to 3, so I just have converted this into kilonewton. You can cross verify. And since the force is in opposite direction, so what I can write here in a highlighted fashion with the red color, when I say F12 bar, it is always opposite of this F21 bar, right? So from that basic assumption, I can write here, if this is your F21, if this is F21, I can simply write here F21 bar is equal to minus F12 is equal to minus F12, and F12 is calculated in previous case. It is minus 1.596 a bar x plus 0.957 a bar y minus 0.597 0.957 a bar z, and unit of this also kilonewton. Unit of force is Newton, and here it's 10 raised to 3. That's why I'm writing it as kilonewton. So if you are solving, you just please check out whether you are getting these answers. If you are not solving, at least you please note down those answers so that in future you can cross verify those answers. These are the answers. Right? So with this, let us stop here for today. Let me once again check the absent numbers, if anyone is present out of them. Roll number 3. Roll number 3 is present. 6. Roll number 6. Roll number 10, 16, 20, 29, 31, 32, 34, 36, 40, 41, 43, 46, 47, 48, 51. Roll number 6 is present. You please don't write it into the chat boxes. Please, you keep on telling me directly. I'm not looking for chat boxes now. 6 is present. Okay, fine. Okay, then let us stop here for today. You are allowed to leave the meeting now.